Hello, let's see how to reduce excessive network latency with Bequant BQN or Cambium QoE, which are the same product. Excessive network latency degrades the quality of experience of users. It has a very bad effect on online video games, sometimes even disrupting them completely. And it can also spoil voice over IP conversations, Teams, Zooms, Google Meet, teleconferences. And beyond a certain network speed, let's say 50, 100 megabits per second, the reality is that latency is what can really determine the quality of a network. First, there's a latency that your users may suffer when you enforce their rate limits. If you use simple queues to enforce those rate limits, their rate plans, they will experience significant excess latency when they reach those limits. If you use, however, active queue management from Bequant, Cambium QoE, Presim, LibreQoS, MikroTik, you will significantly reduce the latency of your network when you enforce your rate plans, almost virtually eliminating them. So let's see an example. Here we will enforce a 200 megabits per second rate plan first with simple queues, then with active queue management, in this case from Bequant or Cambium QoE. We will use the buffer bloat test from waveform.com. So first we'll test without ACM with simple queues. Yep. And now we'll test same thing but with Bequant enforcing the same rate with its advanced AQM and TCPO. Here we go. And that's it. These are the results with simple queues. We see a 22 millisecond increase in latency, a top speed in downlink direction, and an 18 millisecond increase in latency when at top speed in uplink direction. And it's graded as an A kind of network, and it's not supposed to be okay for low latency gaming. However, with the AQM queues from Bequant, the results are much better. It's only 2 milliseconds, 1 millisecond increase at top speed in latencies, and so the network is considered A+ network and okay for low latency gaming for all applications. There are different kinds of active queue management implementations. There are those like Bequant or Presim that are variations of FQCodel, standard method, and others like LibreQoS use Cake, another method, or MikroTik can allow both. In any case, these methods, FQCodel and Cake, they work by dropping packets preemptively to slow down servers so that you avoid latency by adapting the speed of those servers to the rate limit. But in doing these losses, you can end up dropping quite a lot of packets, which may not be so good in some situations like gaming or voice over IP or video in teleconferences. However, in the Bequant implementation, we add TCP optimization, which, apart from accelerating TCP downloads, can adjust the speed of servers with the receive window instead of having to drop packets. In the acknowledgement packets, we tell the server basically up to which point the server can send, and thereby control exactly the speed of sending. So you get with this TCPO plus AQM reduction in latency without incurring in packet losses. But we will now get into a more complicated scenario, still quite common scenario, which is when we have excess latency, but we are not reaching the rate limit. The problem with any of these AQM methods is that they only work when the rate limit is reached. Basically, when a queue forms, we can do something about in that queue, dropping or doing other things. But in many scenarios, a slower node, typically a Wi-Fi router, can be the one limiting the speed. And if that node does not have AQM, a very common situation, you end up with high latency, because it will be the queues, the buffer of this, the slowest node in the path, that will dominate the latency. So we are now going to test this environment, in where we'll have a laptop, and then we'll have a Wi-Fi router, which is limited to around 140 megabits per second. We do that by forcing a 20 megahertz channel instead of a more standard 80 megahertz channel Wi-Fi. And we will be enforcing rate limit with 200 megabits per second, even though that will not in fact do anything, but we will have in addition ACM, our Automatic Congestion Management. So let us just test this first, disabling ACM. This is it, and now that's the grade we get without ACM, where the Wi-Fi router has dictated latency. And now we test with ACM on and see the difference. Okay. Look at the large improvement obtained comparing when we don't have ACM, where basically the latency is dictated by the buffers in the Wi-Fi router. There are queues there, and fairly large queues that basically gives us a very low grade network. And compared with ACM being active, in which case for instance the latency in when at top speed in downlink has gone down from 43 to 17 milliseconds, and when the top speed was in the uplink direction, it went down from 65 to 30 milliseconds, less than half. Enough to go from a C grade network to an A grade network. So how does ACM, Automatic Congestion Management, work? It uses very advanced machine learning algorithms, which, starting from continuous measurements of speed, losses, and latency for each user, it detects situations in which the user reaches a certain maximum speed, and that coincides with high latency and losses. In those situations, it will try to use slightly lower speed and see if that reduces the latency and the losses, and thereby reducing the congestion. And if that works, it will start optimizing that speed limit number, trying slightly up, down to get to an optimum speed limit and with minimum losses and latency. So for any more information, if you want to try this out in your network, please contact us at info@bequant.com or visit our website at www.bequant.com. Thank you.